Dear friends, we are going to discuss about the Markovnikov's rule. The Markovnikov's rule it is discovered by the Valmir in 1870. This is not that much difficult one. It's the simple one, but only the thing is that we have to be listen carefully and we have to be understood well. Then here, in case of Markovnikov rule, before going to discuss about this Markovnikov's rule, we have to be know about the alkenes. Okay. Actually, this reaction, especially Markovnikov rules, it will be comes under in the addition reaction. That is the addition of the alkyl halide. In that we are going to be discuss. Okay. Before going to that addition reaction, then we should have to be know about the what type of alkenes are available. Here I will write alkenes. Basically, here we are going to discuss about the two types of alkenes. Just you can see I will write here. Just observe these two alkenes. I will give the number. This is the one, this is the two. Just see in this case, when we will be divide, when we will be cut into the halves where the double bond is available here. Just you can see here. Then you can be observed around the double bond. Here, this side of the double bond, here two carbons are present. You can see one, two. This side you might be see only the one carbon is present. That's why this alkene is called as the unsymmetric alkene. Unsymmetric alkene. Remember. See in this case around the double bonded carbon you are observing in this case other side of this double bond you might be observing here also one carbon, see two carbon, one, two. Either side similar number of carbons are there either side of the double bonds. That's why this is called as the symmetric alkene. I hope you might be understood this. When cut into the halves, that also okay. When we will be cut into the halves, then we have to be see that other side of the double bond, any unequal number of atoms are there means it is called as the unsymmetric. If it will be having the equal number of carbons, remember if it is having the equal number of carbons means that is the symmetric alkene. But Markovnikov rules it is only helpful for this unsymmetric alkenes only. Which rules? Markovnikov's rule. This is applicable only for the unsymmetric alkenes, not for the symmetric alkenes. For this, it is not helpful, only helpful for the unsymmetric alkene. I hope you might be understood this much. Now, we are going to be discuss about the what exactly these Markovnikov's rules. When addition of the when addition of the hydrogen halide, especially to the unsymmetric alkene, remember that addition of the hydrogen halide to the unsymmetric alkene. Okay, then what type of product it is going to be produced? That is based upon the Markovnikov's rule. The unsymmetric alkene means I will take the propene. I will write here the best example is the propene. This is the propene. We know that this is the unsymmetric alkene. When we will be add the hydrogen halide, I will take the example is the HBr for the hydrogen halide. Okay, better to be choose the some different color. See, according to Markovnikov rule, what it exactly it is going to be happen. In this case, you might be see hydrogen bromide. When it will be ionized, we might be know it is going to be produce the H plus Br minus. What it is going to be produce? H plus. When it will be ionized, generally this HBr it is going to be produce the H plus Br minus. One is the electrophile, another one is the nucleophile. Okay, then in this case just when you will be see according to the Markovnikov's rule hydrogen goes to that doubly bonded carbon. Listen carefully, hydrogen goes to that doubly bonded carbon which is having the more number of hydrogen. Listen carefully, which is having the more number of hydrogens. Doubly bonded carbon only I am saying. Around the double bond, two carbons are there. In the two carbons, which is having the more number of hydrogen, this hydrogen goes to that carbon only. Now, in this case, you can see which one will be having the more number of hydrogens. This is, I can call as the first carbon. This is the second carbon. This is the third carbon. See, in this case 1 and 2, because doubly bonded carbon means 1 and 2. Around the 1 and 2, which is having the more number of hydrogen, means carbon number 1 having the more number of hydrogens. Listen carefully. Which one having more number of hydrogen? Carbon number 1. It is having the more number of hydrogen. It is having 2. But here carbon 2 having only 1 hydrogen, but carbon 1 having the 2 hydrogens. It means what? This hydrogen, it goes to that doubly bonded carbon which is having more number of hydrogen. I hope you might be understood this. Now see what I told. This hydrogen, this double bond, it is going to be attack on this hydrogen. I am showing reverse here. Okay, but this double bond going to be attack on this hydrogen. This hydrogen is particularly, it is the electrophile. Electrophile means which loves the electrons, means deficiency of the electron it is having. Okay, then it is attacks on this pi bond, but this hydrogen goes to that doubly bonded carbon which is having the more number of hydrogen, means carbon 1 having the more number of hydrogen. That's why you can see the reaction here. Now see what I told, hydrogen goes to that doubly bonded carbon which is having the more number of hydrogen. This is having the more number of hydrogen, means whatever the electron pair is there, 2 electrons are there on the double bond, it is taken up by this hydrogen. Okay, taken up by this hydrogen. Okay, this H plus, because it is the deficiency of the electrons, that's why attack the pi bond. Then here what it will be going to be get? Positive charge, carbocation. What? Carbocation. Then here carbocation it is going to be formed, means which is going to be attack here? Bromide will be going to be attacked. Then what it will be formed here exactly means? The hydrogen halide, when it will be ionized, hydrogen it goes to that doubly bonded carbon which is having the more number of hydrogens. The more number of hydrogens. Okay, then the halide, where it will be goes then? Obviously it will be goes to the another carbon where the electron deficiency is there, because electron deficient carbon attacks the bromide, bromine having the pair of electrons. That you will be understood in the mechanism. Now what? According to the Markovnikov rule, hydrogen goes to that doubly bonded carbon. Hydrogen goes to the doubly bonded carbon which is having the more number of hydrogens. This one having the more number of hydrogens. This is having the less number of hydrogens. Then what it will be going to be formed? This pair of electrons going to give to the hydrogen here. Okay, then here it is the carbon 2, this will be the electron deficient, then it will be attacked by the bromide. It means what product it will be formed? 2-bromopropane, that is called as also secondary alkyl halide, also known as the Markovnikov's product. For the mechanism, see first step what I told, ionization. In ionization what happened I told, when the hydrogen bromide it is ionized, what it is going to be produced? H plus, then Br minus. H plus Br minus. This is only, this is pair of electrons, both the electrons taken away by the halide. Hydrogen, no electron with this, but the pair of electron taken up by the bromide. Okay, this is called as the ionization process. Now this electron deficient electrophile, H plus means it is electrophile, electron lover. Okay, it loves the electrons because it don't have the electrons. That's why it undergoes the process of protonation, means addition of hydrogen. Here you can see the addition of hydrogen to the alkene. I will write alkene here. This is called as the propene. Okay, then see here it will be react with the electrophile because it undergoes the protonation. The protonation, what happens generally? It produces the two types of products. Just see here in this case what happened. This hydrogen, one chance is there, it will be goes here. Then the another chance also there, where it will be go this hydrogen, this carbon. But according to Markovnikov rule, it goes to which carbon? Which is having the more number of hydrogen. This carbon having the two hydrogens. This is having the only one hydrogen. That's why it will be goes to this carbon. Now see, we will write both. When it will be attack on the, this is first carbon, this is the second carbon. Okay. When it will be attacked on the first carbon, see here what happens. Here it goes to, according to Markovnikov rule, that carbon which is having the more number of hydrogen. Both the electrons occupied here. That's why this carbon become electron deficient. What it is? Electron deficient, this carbon, because both the electrons which is in the form of double bond given to what? Hydrogen. Okay, this is called as the secondary carbocation. We'll write properly. Secondary carbocation. Secondary carbocation. See another product what it will be formed, this hydrogen attack on this second carbon, means which is having the less number of hydrogens. What product it produced? Just check it. CH3, CH, CH2. Just see here. Here it becomes the positive. Why it is become positive? Means hydrogen goes to this carbon. Okay. The carbocation present where it is present? On the first carbon it is present. That's why it is called as the primary carbocation. Okay. This is the secondary. This is the primary. Now we should have to be know about the stability of the carbocations. You might be studied the intermediates which is going to be formed in between the reactions, like carbocations, carbon ions, carbons. All these are the reaction intermediates. Free radicals, all these are the reaction intermediates. Okay, now carbocations which are more stable now here. Okay, now at that time the stability order of the carbocation, tertiary more stable than the secondary, secondary more stable than the primary. I hope you might be understood. Now which one having more stability here? This is the primary, this is the secondary. Which is more stable, primary or secondary? Secondary is more stable. That's why this reaction is possible, this is not possible. That's why here we are saying that it is the Markovnikov's product. This one is the anti-Markovnikov products. Anti-Markovnikovs. This is the Markovnikov's products. This one is the Markovnikov's product. This is the anti-Markovnikov's product. Markovnikov product means which carbocation? Secondary carbocation more stable when compared to the primary carbocation. Okay, that's why next step, just see, we are considering only the secondary carbocation. Why secondary carbocation we are considering here? Just see, I will take the secondary carbocation here. Secondary carbocation. Why I am taking secondary? Because secondary is more stable than the primary. Okay. Now you can see what product when it will be. Next it is react with the bromide. Bromide which is having the more electrons. It is called as the nucleophile. Means it loves the nucleus, electron deficient. That's why easily this is going to be attack on this carbocation. Then what it is going to be produced? Just see what product it is going to be produced. This is called as the secondary alkyl halide, or this is also called as the Markovnikov's product, or this is also called as the 2-bromo-propane. Okay, you might be understood. In the first step, what we discuss? Ionization. Ionize to form what? Ionize to form the electrophile, nucleophile, because nucleophile having both the electrons. Okay, next step, protonation. Hydrogen going to be added according to Markovnikov rules. What? Hydrogen goes to that doubly bonded carbon which is having the more number of hydrogens. This is having more number of hydrogens. That's why what it will be formed? Secondary carbocation. Okay, it is forming the, just see what it is going to be formed, secondary carbocation. Okay, now in the second step we are taking the secondary carbocation only, because secondary more stable than the primary. That's why we have to be take more stable one. Then this bromide attack on this electron deficient carbocation to produce what? Secondary alkyl halide. This is according to whom? Markovnikov's. Okay, what is the reason to be formed behind this one? Already I told, alkene. Okay, initially it is react with the hydrogen. Okay, it undergoes the protonation. It going to form the two types of products, two types of intermediate. Absence of peroxide. I will tell you. Next we will be discuss about the peroxide. This is in the presence of peroxide. Absence of peroxide, Markovnikov product it is going to be produced. When it will be attacked, where it will be attacked, and which that carbon, doubly bonded carbon which is having the more number of hydrogen, then which intermediate produces? Secondary carbocation it is going to be produces. Okay, then here what? In this case, primary carbocation, because this hydrogen attacks on this carbon which is having the less number of hydrogen, that is happen in the presence of peroxide. Absence of peroxide means it is the Markovnikov's rule. Absence of peroxide means Markovnikov rule. Okay, don't forget that. Absence of peroxide means what you will be write in the examination. Absence of peroxide means it is equal to the Markovnikov's rules. Okay, now see here what it is going to be formed. Hydrogen will comes here, then here it becomes the electropositive. This carbon will be get the positive charge. Positive charge present on the first carbon. That's why it is called as the primary carbocation. Carbocation is nothing but carbon containing the positive charge. This is the secondary carbocation. Okay, secondary carbocation. This is secondary carbocation. Now see in the next step what happened. What I told, bromine. Bromine is the electron rich, which is having the one pair of electrons. That's why here what it is going to be formed. It forms the Markovnikov's product. Just see here hydrogen, here bromine. Here you can see in this case, here hydrogen, but here bromine. This is what product? Secondary alkyl halide means based on what? This, what is the product name of this? This is called as the Markovnikov's product. This one is the anti-Markovnikov's. Anti-Markovnikov's means you remember that peroxide effect. Here there is no peroxide, absence of peroxide. Okay, absence of peroxide means it follows the Markovnikov rule. Okay, I hope you might be understood. What is the reason behind this? One is producing the secondary carbocation. What it is produces here? Secondary, here primary. Then which product it will be follows? Why it will be it forms the Markovnikov product? Secondary alkyl halide means secondary carbocation more stable than the primary carbocation. That's why bromine will be attack on this secondary carbocation only to produce what? Markovnikov product. The reverse it is going to be happen. When it is going to be happen reverse, that is in presence of peroxide. Okay, in that time the hydrogen it goes to that carbon which is having the less number of hydrogens. See, this is having less number of hydrogens. Here it will be go to produce what? Primary carbocation. That attack with the bromine, then anti-Markovnikov product it produce here Markovnikov product. Okay, I hope you might be understood what is the reason behind the Markovnikov's rule. Okay, Markovnikov rule means what I told. Hydrogen goes to that doubly bonded carbon, okay, which is having the more number of hydrogen. Doubly bonded carbon only I am saying. Okay, this we are discussing only for the unsymmetric alkenes. Remember, for what? Unsymmetric addition of the hydrogen halide. Okay, I hope you might be understood this.